Hello everyone, welcome to the session. So I hope that before watching this video, you already have covered up my previous session where we have talked about introductory of machine learning. What is machine learning all about, right? Then we have talked about the history and evolution of machine learning, and we have seen that this domain is not something which is coming up now. It's been 1980s time where the concept of machine learning was coined, right? Now, in this session, I'll talk about the types of machine learning that we have because considering you all as a beginner, we should know that how many different types of data that we have, followed by how many categories of machine learning algorithms we have, which we will cover up in the upcoming sessions. Okay, so without wasting any time, let's get started to understand the types of machine learning. So here, whenever I'm talking about the types of machine learning, I will categorize into, you can say, three components. Usually you will see in maximum standard books and websites that categorize into three components, but I'll talk about the fourth component as well in this session, okay? So basically the very first version which you will see is, you can say, supervised machine learning algorithm. Supervised machine learning algorithm. This is the first category of a machine learning algorithms. So let's talk about this in a great detail before moving to the next category, okay? Let's consider, as we have seen that whenever we are talking about the concepts of machine learning algorithms, we are trying to take historical data and we are trying to train that data set, right? This is what we have understood in the previous session. Now, let's say that I am providing you one problem and that problem is belonging to a healthcare domain. And specifically, if I'll talk about the problem statement, let's say I will provide you the data set of patients which are having diabetic and which are not having diabetic. So there are people who are diabetic and there are people who are non-diabetic. Listen my problem statement very carefully, okay? When I'm saying diabetic means it belongs to class 1. When I'm saying non-diabetic means it belongs to class 0. Okay? Now, what is the problem statement? Obviously, you have to design a model which gives me a prediction, right? Which gives me the output whether it is 1 or 0, means whether the patient will be diabetic or not. Now, obviously, to determine that whether the patient is a diabetic patient or not, we require the input data. You can say we require the records of the patients which are diabetic and which are non-diabetic so that our model will try to learn the patterns. This is how basically the algorithm work, right? So what we have is, let's say I'm providing you a set of features. For example, we will be having feature F1, F2, F3, F4, F5. And corresponding to every feature, when I'm saying feature, it means the columns that we have, we will be having a target value. Now this target value is either 0 or it will be 1. 0 indicates a person is non-diabetic, 1 indicates a person is diabetic. Okay? This is a numeric data that you have, and you can say that maybe they're providing a BP of a patient, insulin level of a patient. Like that, there are 5 features that we have. And corresponding to every feature, we will be having a target value, which is either 0 or 1. Means either the patient will be diabetic or the patient will be non-diabetic. Now, basically, for every record, for example, if let's say you will be having 1 to 1000 number of records, okay? For that, you have a target value which is labeled as either 0 or 1. And then you are trying to provide a training to the model, splitting your data into training and testing. How the complete flow will go, I'll explain in the later part of the sessions also. But as of now, just think over it that we will be having a kind of a data set. This is something which we call as a data set composed of rows and columns, where the columns are something which we call as a features. So we will be having columns, which is what I will say in my sessions as features of that data. We will be having rows, which I will say as a set of records that we have or data points that we have in machine learning terminology. This is what we usually say. Okay? Now, just try to understand what I'm trying to convey here. For every particular row or for every particular record that I have a corresponding target value, which is either 0 or 1, right? What I'm saying is I have a corresponding target value, which is either 0 or 1. This kind of problem where you will be having for every record, the target value, the label value is something which we call as supervised machine learning algorithms. Wherever you will be having a data which is having a target value available to you. So to train that kind of a data, you will always have a supervised machine learning algorithms. So what is the meaning of supervised machine learning? It means that, simple in literal terms, it means that labeled, or you can say target data is given in the data set. Simple. Very, very simple. I hope it makes sense to everyone what I'm trying to convey here. Target data, or you can say the label data, is given in the data set. That is something which you can call it as a supervised machine learning. Okay? Now, in this case specifically, where we have to provide either the value as 0 or 1, is something which you can call it as a classification problem. Okay? So always remember one thing, that the first thing is, according to the given data, you have to determine that whether this is a supervised machine learning or not. If it is a supervised, how will you determine? A target column is given to you or not. If it is given, then it's a supervised. Now you have to check that in that data, what is the target you want to predict? Either it is 0 or 1, or it is something else. What is that something else? Maybe continuous values. For example, let me give you second problem statement. So this is the problem statement 1, where we have talked about the first example, which is of healthcare domain. So this is the example number 1, right? Example number 1. Now I will provide you example number 2. Again, try to listen my problem statement very carefully. Let's say I am providing you again the set of features. Feature F1, feature F2, feature F3, feature F4, and feature F5. When I'm saying feature, again I am saying it's a column. And corresponding to every feature, you will be having a target value. And in this case, the target value is the house price. And you want to train your model in such a way that after learning from this data set, your model will be able to give me the prediction that if I'll provide you the features F1, F2, F3, F4, F5, what is the optimal target value of a house price? Let's say the feature can be the number of bedrooms, right? Is it a 2 BHK or 3 BHK or 4 BHK, depending upon the price level will be varied. Then locality or the area, right? Then maybe number of bathrooms and so on. So these are the features. Corresponding to these features, our price of the house will be varied for sure. Now here, if you will observe, the price of the house is something which is a continuous value. Maybe you can say it is a 2.04 CR. You can say the first record house price is this. Second crore house price is, let's say, 1.23 CR. Third row house price is, let's say, 50 lakh, and so on. So basically what is happening here, if you will observe, again if I'll ask you, is this a supervised machine learning? You will say yes. Why is yes? Because the target value is given to you corresponding to every record. So again, let's say if you will be having 1000 records, so corresponding to those 1000 records, if you will observe, a target value is given to you. A target value is given to you in the complete 1000 records. So here, if you will observe, it's a supervised one, but it's not a classification problem. Problem per se, this kind of problem is something which we call as a regression problem. Regression problem. I hope it is clear to everyone. So what I have just now explained, I have explained you about what is a supervised machine learning, where I have said you that wherever in a given data set, a target value or target column is given to you, that is something which we call as supervised machine learning. And in that supervised machine learning, we have categorized into two components. One is something which we call as a regression. Second one is something that we called as a classification. Classification, right? Regression meaning the target value that you want to find out belongs to what? Belongs to continuous numbers. Okay, you want to predict some continuous numbers. Classification means that here the target value belongs to some class. There will be some class, either 0, 1, 2. It can be binary classification. It can be multi-class classification problem. So let's go back to the screen and what we have seen. In supervised machine learning, we have seen that we will be provided the label data and it will be useful on classification as well as on regression task. So this is the important point that you have to understand. Make sense? Now let's talk about the second category that we have, which is unsupervised machine learning. So let's go back to the screen. Now, whenever I'm talking about this unsupervised machine learning, this is the second category. So until so far I have talked about first category. Now let's talk about the second category, which is unsupervised machine learning. What is this all about? Let's try to understand this concept as well. When I'm talking about this unsupervised machine learning, it is just the opposite of what we have discussed just now for the supervised one. Meaning, let's say you will be having a data set, but in that data, target value is not available. So in any kind of a data where target column, which you also called it as a labeled column, if it is not available, then that kind of problem is something which we call as unsupervised machine learning problem. For example, just a very simple example which I want to give to you is, I hope you went to a grocery shop, maybe a big bazaar in the malls or the hypermarket, where you will observe that, let's say people are working there, okay? And there is a different blocks are there for every particular product that we have. For example, grocery items are at one block. Maybe sanitary items are at another block. Maybe you will observe that Maggi and all those stuffs are at other block. You will observe that all the body wash are at the other block. So what you will observe is that there is a different blocks that we have where the products are being assigned. If let's say tomorrow a new person will come in that particular hypermarket and he wants to work in that hypermarket, what do you think? Is there any problem he will be facing to assign the products? No, right? Because there is a different groups that we have, so he will just check it out which particular group that body wash or Maggi belongs to, and he will go and directly put it there. So what I'm trying to convey here, please try to understand. Wherever you want to classify the customers or classify the things which you want to work on, that's where the concept of clustering came into picture. So clustering is something that we have in unsupervised machine learning. For example, I will say to you that, classify the credit card ratings or on the basis of a CIBIL score, on the basis of a credit card score. Just tell me three groups, three clusters. One group who's having a salary of maybe more than 1 LPA. Another group which is having a salary between 50,000 to, let's say, 1 LPA, right? Or having category which is less than 50K, right? Which is bigger than 50K. So there is a 3 customer base we have, C1, C2, and C3 on the basis of the features that I'm providing to you. So what I'm providing is the details of the financial transactions. Obviously, banks will provide that. And if you will observe, you will get a loan and you will get a lot many calls, which is very frustrating at times. On the basis of what? On the basis of your CIBIL score, on the basis of your transactions that you made every month, they usually call and provide a loan to the customers. And that loan will always be helpful for the bank people, because that's where they will generate the revenue if you will not able to repay the amount. So by saying that, on the basis of the patterns of the features that we have, we can define the clusters, we can define the similar groups. For that, we don't have the target value as of now, but we are trying to create that. So that's what we called as unsupervised machine learning, where the concepts of clustering algorithms came into picture. So if I'll just go back again to the screen, here we are training on unlabeled data. That is what I have explained, useful in clustering and anomaly detection. I'll talk about anomaly detection as well. It's kind of outliers that we have in a given data, means extremely awkward points that we have in a data set. I'll talk about that in a later part, but yeah, this is what we have called as unsupervised machine learning. So until so far, we have talked about two categories. One is the supervised one, another one is unsupervised one. How will you get to know? By given the data set, you will be able to understand if the target value is given to you, it's a supervised one. If it is not given to you, it is an unsupervised one. Very simple, right? Now, there is a third category, which is not mentioned in the screen, but I'll talk about that, which we call as semi-supervised. Semi-supervised machine learning. You might use this particular thing in the industry a lot. Now, what usually happens is that in a real world practical scenarios, we don't have very huge amount of label data, specifically in various domains like healthcare. So what usually happens in that scenario? Let's say we will take an example of a healthcare domain itself, because in healthcare, labeling is very tedious task, because doctors will not have the time to label. And without doctors, we can't, as a normal human being, label the things as diabetic or non-diabetic, cancerous or non-cancerous, depending upon the given features, right? Only doctors can do the labeling, and they don't have the time, to be very frank. So labeling is a very tedious task. Now, what usually happens, let's say we will be having a problem of, again, I'm taking a same example, diabetic or non-diabetic. Means it's a classification problem where we will be having a class of 1 and the class of 0. Let's consider a scenario. Now, let's say I'm saying that out of 1,000 records that we have, 500 records are there which are labeled. Which are labeled means we will be having a target value corresponding to that. Okay? But there are remaining 500 records that we have a patient data of 500 records, but we don't have there is no target value which is available in that case. Now, please try to understand, this is a different situation from the situation that I have talked about in the above cases, whether it be supervised or it be unsupervised. In supervised, we completely have 1,000 records having a target value. That's what I have explained. In unsupervised, we completely have a set of 1,000 records which are not having a target value. But now I'm talking about semi-supervised, where maybe almost half of the records are having a target value, half of them are not having target value. And that's the kind of a situation that you will feel in a real-time industry use cases. So when you will enter in the industry, or whenever you will do a research work in any of the domains, you will find out that there are specific domains, like I have given you the example of a healthcare, where this is a very biggest issue. We will be having half of them are supervised, half of them are unsupervised. Then what we will do, that's the biggest question. That kind of a category is something which you can classify it as a semi-supervised, because half of the data is supervised, half of them is not. Now the question is that how we will be able to solve this problem, right? So the question is how we will be able to solve this problem. Now, what we can do in this case? What you will do? You will say that what I will do is, first of all, I'll focus on this 500 records which are not having any target value. And this is what we usually call it as a unsupervised one, right? Because just now we have discussed unsupervised machine learning are those which is not having a target value. So what you will do? you will apply the clustering based algorithms on this data. Clustering algorithm. Now, what will happen when you apply the clustering algorithm? You will be able to get two clusters. One cluster belongs to class 0, one cluster belongs to class 1. So you will be having cluster 0 and cluster 1. It means that now for your 500 records where the labeling was not there, you have made a label. Maybe 250 records are there almost which belongs to class 0 and 250 records are there which belongs to class 1. Now you got the labels. Now what you will do? You will merge these 500 records which were not having a target value, but now we have, because of the clustering algorithms, we merge them, and then now we will be having in total again 1000 records. 500 records are already labeled. 500 we have labeled by a clustering algorithm. Again we have 1000 records, and now what we can do is we can apply the supervised machine learning technology algorithms that we will discuss in the upcoming sessions. What are the algorithms that we have? But now our problem of giving the prediction of 0 or 1 will be solved. Now you can ask me one more question, that why is there is a need to add these 500 records? Why can't we directly go and do the task completely on these 500 records? The answer is we can do, but higher the data set that you have, there is a high chances that you will be able to get a good accuracy. It's the better knowledge you will be able to gain, the more knowledge you will be able to gain, the more expertise you will be able to have for that subject, right? Similarly, when you are providing the data set, make sure that you will provide enough data so that your model will be able to give you the accurate predictions, right? So if I will be having 500 records, patients' data that is so crucial, why will not I utilize that? So I will utilize that by doing the unsupervised machine learning algorithm first, getting the predictions first, clustering clusters first, then merge them with the remaining 500 records. That's the simple scenario which we usually use in the industries as well. Now let's move to the fourth category, which was the last one, which is the reinforcement learning. So usually the third category which I have talked about just now, usually people not considered as a separate one, but just to make you guys clearly explain the concepts, I have made it separated, okay? Reinforcement learning. So when we're talking about reinforcement learning, this is different altogether from what we have discussed in supervised, semi-supervised, and unsupervised. What it says is that I'll train the agent or the model, and it will do the action on the basis of the environmental factors or environmental variables, right? What is the meaning of that? I hope that you must have seen self-driving cars, or you must have at least heard of this self-driving cars, right? Many people have also seen that, at least in tier 1 cities. Not that much is famous, but yeah, we have. Outside India, you will be definitely able to see in US and many good developed cities, you will be able to see this self-driving cars. Now, this self-driving cars is completely built upon this reinforcement learning, where on the basis of the environment, the model will take some action, right? What is the meaning of environment? For example, let's consider the scenario of a self-driving car itself. Let's say if any obstacle will come, automatically that self-driving car will apply a brake. So on the basis of that environment, it will take some action. Now, when the training usually happens for these cars, either a reward will be awarded or a penalty will be given, depending upon the action. So if that, let's say it's called as an agent. If that agent or the model will take a good action, will provide the reward, which indicates that, okay, you are taking a correct action. If it is taking a wrong action, will provide the penalty. That is how better the action, higher the reward. Bad action means higher the penalty. This is how the complete learning usually happens, depending upon the environmental variables. So if I'll go back to the screen, you can see that here the training on agent will be happening to take the actions that maximize a reward. So here what we want is, ultimately we want to maximize that reward, means we want actions to be very much apt, because if you will talk about self-driving cars, it's a very important use case where if suppose a person is completely relying on the car, we have to make sure that the car is working properly fine. Wherever there is a red signal is there, it should stop. Wherever there is an obstacle is there, it should stop, right? Wherever they have to change the gear, it should change, like that. So that is something which is a part of reinforcement learning. So this is the overall talk about today's session, where we have talked about specifically the types of machine learning. We started with the supervised machine learning, where I have talked about that given a data, if suppose a labeled data is given to you, it's called as a supervised one. I have given you a practical use case of a diabetic patient data. Further, I have classified that supervised into two important problems. One is regression, another one is classification. The second important category which I have talked about is unsupervised machine learning, where I have said you that if there is no labeled data is given to you, that's something which we call as a unsupervised one, where the clustering usually happens. Means similar items will be grouped together. The last one is something which we have talked about, reinforcement. Before that, I have talked about semi-supervised, where I have again provided you a use case of a diabetic patient, where half of the data is a labeled one, half of them is an unlabeled one. At the very end, we have had a great discussion about reinforcement, where we have talked about the example of a self-driving car and have tried to understand the use case, where depending upon the environmental variables, agent will take an action that will maximize the reward. So this is the overall idea behind the types of machine learning. In the upcoming section, I'll talk about now the applications of machine learning. So stay tuned, and I'll see you all very soon in the upcoming videos.